Math 0324 for Monday, August 1st, the third full week of the semester. We're going to be working on, come in here to Math 0324, assignments. So this week there's technically 1, 2, 3, 4, 5, 6, 7 homeworks to work on. But actually the last one is kind of a unique one where it's just got one problem. So it's really like 6 then, not counting that one. So we'll do 2 per day, 2 today, 2 tomorrow, and 2 Wednesday, including that. We'll just throw that last one in at the very end. So today should be homework 13 and 14. Homework 13 and 14 today, 15 and 16 tomorrow, and the rest on Wednesday. Homework 13, graphing linear equations using x and y intercepts. Okay, so this is one method of graphing a line. It doesn't work on every single problem, but when it does work, it's probably easier than anything else. 8x minus 2y equals 8. Oops. So homework 13, problem 1, 8x minus 2y equals 8. Okay, so x and y intercepts. An x-intercept is the place where the graph crosses the or touches the x-axis. If you're talking about a line can only do it at most once. So there's going to be one x-intercept and one y-intercept on these because these are all diagonal lines. And then this is what's the best way to remember these is an x-intercept occurs when you have 0 for the y-coordinate. And that's how you find it. You find an x-intercept by putting 0 in for y. And plugging zeros in is really nice because anything times 0 is 0. So this part here is 0. And anything plus or minus 0 is itself. So literally it just disappears. So you don't have to do this every time. When you plug 0 in for y, this whole part disappears and you're left with just 8x equals 8 right there. Divide by 8. 8 divided by 8 is 1. So we plug 0 in for y and we got an x of 1. That's a coordinate 1, 0. And then we turn around and do it again for the y-intercept. A y-intercept has a 0 for x. And that's how you find it, is you put 0 in for x. It's going to make this whole part disappear. You're just going to be left with the rest. Negative 2y equals 8. Divide by negative 2. Y equals negative 4. So these are 2 points on a graph. If you have an xy axis, remember x is horizontal, y is vertical. The coordinate 1, 0 is 1 to the right and nothing up or down. In coordinates, you do the x first. 1 to the right, nothing up or down. 0, negative 4 is nothing left or right, and negative 4y is down 4. So you put your 2 dots and then you just draw a line through them. And this works very well as long as both of these given numbers divide into the equals number. But if I change this 8 to a 9 or a 7.2, then this method doesn't work very well. So in the times it works well, then it's the least amount of work basically, and you get to work with easy zeros. So to do this, you just click anywhere on the graph, the toolbar pops up. Get to the line tool, and then you want it, the order of these two doesn't matter, so I'll just go to 1, 0 first and click that. And then when you move to the other one, the line kind of draws as you're going. 0, -4 is right there. And I got those two spots marked off. This is not the only way to do it, but it's a good way. Okay, so I guess this is the same, but notice how they're putting 0 in for x. That's literally going to make the 2x disappear. So you'll just be left with 6y equals 96. You want to get rid of that 6, so divide both sides by 6. 96 divided by 6 is 16. So if x is 0, y is 16, and that would be a coordinate on the graph up 16 from the origin. Then if you plug 0 in for y, the 6y will disappear. 2x will equal 96. So divide both sides by 2. 96 divided by 2 is 48. Now, technically, if you know you have a line, that's all you need. A line goes through 2 points. It's not the worst thing in the world to double check and do another point. They've got 3 points here. This, especially on a test, it doesn't hurt to do this. If you know for homework you got these two, you can just do it. And why they pick 6 is debatable too, but put a 6 in for x. You could have put a 1 in for x or a -3, but for some reason they chose 6. And then you'd have to work that out. 2x plus 6y equals 96. 2x plus 6y equals 96. Plug a 6 in for x. Plugging 6's in isn't as easy as plugging 0's in. In fact, 0's are the easiest one to work with. So now we have to do some calculating, some algebra. 2 times 6 is 12. Minus 12. (96 minus 12 is 84. Divide by 6. 84 divided by 6 is 14. So that's another coordinate, 6, 14, kind of as a double check. I guess we're not graphing yet, but that's what you could do then is you could plot all 3 of these points on a graph. It's a little hard with such large numbers, but 0, 16, I'll just call that right here. 0, 16 is up 16 from the origin. And then 48, 0, that's really hard to do, but 48, we'll just put it way out here and say there's 48. 48, 0 is 48 to the right of the origin. That's all you really need to draw this line. But that third point's a double check, 6, 14. I'm not going to be able to double check here, but if I had graph paper, I could check where's 6 and 14. Is that on the line or not? It should land right on the line if you go over 6 and up 14. So that's why they included that third point, even though it's not absolutely necessary if you just care about graphing. Okay, so again, they got 3, but plug 0 in for x first. That'll get you the y-intercept. This 2x will disappear. Now the -2 will still be there on the y. So divide both sides by -2. 4 divided by -2 would be -2. Instead of putting it up here, they're making you put it down here. And then this is another issue too, is it says type an ordered pair. So if you were putting in this table, you would have 0 for x, -2 for y as a coordinate that's 0, -2. Whoops. Sometimes they just ask, what's the y-intercept, and you just say -2. Other times they'll say type an ordered pair, and then you got to put it in as a coordinate. That would be down 2 from the origin. When y is 0, the -2y part will disappear. 2x equals 4, divide by 2. 4 divided by 2 is 2. So it's actually 2, 0 for an ordered pair or coordinate. 2, 0. That's 2 to the right of the origin. So if you were graphing this, which I don't think you are, but if you were, that's all you need. 0, -2 is down 2. 2, 0 is right 2. There's the line right there. This is just a double check. If y is -4, I would get -4 times -2. That would be +8. So then you would have 2x plus 8 equals 4. Subtract 8. Four minus 8 is -4. Divide by 2. X would equal -2. X would equal -2 when y was -4. So if you go 2 to the left and down 1, 2, 3, 4, and again on graph paper would be better, but 2 to the left, down 4, that's right there. See how that's on the line too? So that's a way to make sure it makes sense. Sometimes people get these first two coordinates mixed up. I've seen this one, especially right here, get messed up. 0, -2. It's actually down 2 from the origin, but some people think it's there. So if you would have graphed 2, 0 here, and then you thought 0, -2 was over there, or even if you thought 2, 0 was up there, then you would either have a line going like this or a line going like that. But then if you did 2, -4, I'm sorry, -2, -4 is down here. That doesn't line up with either one of those two. So that's that double check where you know something's wrong. If you do 3 points and they all line up, then you know you did it right. But if you only do 2 and one of them has a tiny mistake in it, you'll never know that anything's wrong. Now, when you're doing homework, then people just put an answer in and check answer and they tell them if they're right or wrong. But on quizzes or tests in the other class, you don't get to put an answer in and see if it's right till after it's graded. So it's always good to have double checks when possible. Okay, so, and now they're just adding more points. You can do as many points as you need. When you get past linear equations, sometimes it's helpful to do 4, 5, 6 points to know what's going on. So first they want me to do it when x is 0. That's an easy one. When x is 0, the 3x will disappear. -2y equals 6. Divide both sides by -2. 6 divided by -2 is -3. And if I was graphing this to double check, 0, -3 is here. When I plug 0 in for y, this part disappears. 3x equals 6. Divide both sides by 3. 6 divided by 3 is 2. So the next coordinate is 2, 0 on the graph, which is right there. I already have enough to draw a line if those are correct. And these next two will be double checks. So what if x is -2? Put a -2 right there where that x is. 3 times -2 minus 2y equals 6. You'd have to work that out. 3 times -2 minus 2y equals 6. So 3 times -2 is -6. Do the opposite of -6 and add 6. That does not affect this negative right here. Watch out for that. I see people drop that all the time. 6 plus 6 is 12. Divide both sides by -2. See, this is harder than plugging a 0 in. That's why if you have a choice, you pick 0 over other numbers. 12 divided by -2 is -6. So when x is -2, y is -6. That's what this point right here is. This is left 2 and down 6. And it should be right in line with the other points if you've calculated everything correctly. -2, -6 is another point. Finally, if I plug -2 in for y right there, plug a -2, you'll get 3x minus 2 times -2 equals 6. 3x minus 2 times -2 equals 6. -2 times -2 is positive 4. Minus 4. 3x equals 2. Divide by 3. And this is an issue sometimes 2/3. When y is -2, x is 2/3. 2/3 is about here for x, 2/3 of the way towards 1. And y is -2 at that spot, so that's this right here. It's not hitting at an exact spot. So that's the downside that can happen. And when that happens, normally that would just be a point you wouldn't want to work with. But if you were using just a double check, you could say, is my line approximately going through that or not? This is also the downside to the x and y intercept method, is sometimes you can't divide evenly and you get fractions and you can't really put them on a graph unless you see the graph and are just double checking it. Okay, is this the same question with the graph? Okay, no, okay. Okay, so now they want me, see, I was doing this over here. I thought I was on a new problem, but this is the same problem. They're looking for these dots here, 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 and here. Which choice has all 4 of those? It's definitely not that. That's wrong. Could be this one. And that's wrong. So yes, this one. Because there's that y-intercept that we did. There's the y-intercept, there's the x-intercept. This doesn't have them in the right spots, and neither does this one, and that one's going the wrong way. So that's exactly what you do this for, is you put your points down and then you can draw a line through it. Okay, this is backwards. What if the graph is already drawn and a diagonal line can only cross the x-axis once and the y-axis once? So there's only one x-intercept and one y-intercept for a line. If we get to curved types of graphs, then it can be more than one. So find the x-intercept as an ordered pair by just looking at the graph. You don't have to solve anything. It's literally this point right here. But since that's 2 to the left and up nothing, the coordinate is -2, 0. It's important where the 0 is. That's not the same thing as 0, -2. In fact, that's what this one is. This one down here is 0, -2, because 0, you move nothing left or right. -2, you go down 2. So that was a quick, easy one. Okay, graph the equation by plotting points, okay? Complete the ordered pairs. This is another strategy, is just plugging in some x's as needed. Now, if I was doing this, I might not pick these exact 2 x's, but so before we were plugging 0 in for x and 0 in for y, but you don't have to do that. You can just plug in for x every time if you'd rather work with x. So if x is 0, that would be a nice one, because the x would disappear and you would literally be left with y equals -5, which is this spot right down there. We're going to do that in a minute. So for whatever reason, somebody wants to plug -5 in for x. That's not the best choice to do, but they're just making you practice this. So if you have y plus x equals -5, and then what if you put a -5 in for x? I would probably plug positive number in, but so plus a negative is the same thing as minus. Then I could add 5 to both sides. These opposites cancel out, leaving just the y. And in essence, they cancel out here too. But you can't have a blank side of an equation. So the reason they cancel out here is they add up to 0. Negative 5 plus 5 is 0. And if you have y plus 0, that's the same thing as y. But if they cancel out here and there's nothing else there, then you literally have 0. So y equals 0 is the other coordinate. When x is 5, y is 0, which happens to be an x-intercept. And this turned out to be the y-intercept. So then, I guess we have to check that first. And now you click anywhere on the graph, click the line tool. 0, negative 5 is down 5. Negative 5, 0 is left 5. So you don't have to plug in 1x and 1y. You could plug 2 x's in if you want to do that. There's many different ways to graph. It's not every situation is done the same way. There's times where different methods work better. Okay, we're back to intercepts though. Find the x and y intercepts for x minus y equals 2. Okay. So remember, x-intercept, it's kind of backwards, but that's when the y is 0. An x-intercept is when the y is 0, because then the x will have some value. Put 0 in right there. X minus 0 is the same thing as x. So literally this disappears when you plug 0 in for it. X equals 2. That's 2 to the right of the origin. Now find the y-intercept by plugging 0 in for x. Now this part disappears. But you do still have negative y equals 2. And you're not done until you have positive y, not negative y. So I have to divide both sides by negative 1. And then the two negatives here will be a positive. Y equals 2 divided by negative 1, which is negative 2. So that's this spot right there. And there would be the line then. So this method worked well here, but again, it doesn't always work so well. But this whole section is about x and y intercepts. So see how it says type an ordered pair? You got to read, do they want just the value of it or do they want an ordered pair? Sometimes they'll just say the x-intercept is 2 and you just put a 2. But here they want 2, 0. The y-intercept turned out to be 0, negative 2 instead of just negative 2. So notice if you do both the x and the y-intercept of a line, one of them ends with 0, the other one starts with 0. So it's important to know where the 0 goes. And that's why they're asking for the ordered pairs. If you put it in backwards, it's wrong. And they weren't even graphing that one. So find the intercepts for the graph. To find the y-intercept, let x equals 0. Remember, it's backwards. If you want a y-intercept, you plug 0 in for x. And then if you want an x-intercept, you plug 0 in for y, but I guess they want us to do this step first. Let x equal 0, put a 0 in for x. Literally put a 0 in for x. 0 plus or minus anything is the anything. So literally the 0 disappears and you just have negative y equals negative 2. Now, you can't have negative y in your answer, you need positive y. So then you divide both sides by negative 1. Negative 2 divided by negative 1 is positive 2. Or think of it this way, if negative y is negative 2, then positive y must be positive 2. So the y-intercept is when x is 0, and then I calculated that y is 2. and that would be up 2 from the origin. To find an x-intercept, you let y equal 0. Intercepts are always about the zeros. So put 0 in for y, but x minus 0 is the same thing as x, so x equals -2. And as a coordinate, that's a -2 first and a 0 second. That's 2 to the left of the origin. And they're not even graphing this one, but 0, 2, and -2, 0. 0, 2 is up here. -2, 0 is over there, so that's this line if you were doing the graph. And notice it's actually parallel to this problem number 7 one. Okay, so only 8 questions in the homework number 13. And I have 100% 8 out of 8 on this now. I got all 8 of them. Okay. So that was homework 13, graphing linear equations using x and y intercepts. 14, I guess they're really changing directions here. And now we're going to do percents to decimals, which is a totally different concept. Got 9 questions here. Oftentimes in problems in higher levels of math, even Math 1324, a problem will have a percentage in it. It's very common in the financial world to quote things in percents. The interest rate is a percent. If you get some problems where you're doing success rates, they'll do those in percentages. Most things are quoted in a percent. And anytime you have to answer as a percent, you're going to put a percent, obviously. But all math calculations, it's best to work in decimals instead of percentages. So it's very common that we go from percentages to decimals first, do our math work, and then we translate back to our percentage. Write this fraction as a decimal. 5 divided by 8 as a decimal is 0.625. And then they're probably going to have you change that to a percentage next. So I guess this problem's not doing that, but that's what you would do. So if you get 5 divided by 8 somewhere, type it in a calculator, get the decimal, 0.625, and then the step that they're going to teach you eventually is to change a decimal to a percentage. Decimal to percentage. Percentages are larger than decimals. They look larger. So it's always about moving the decimal twice when you go back and forth between these two. So it could be easy to forget which way you're going, the 2 decimals. But you would do 2 decimal places this way, 62.5%. 62 is bigger than 0.6. So the percentage always looks bigger. But 0.625 as a decimal is 62.5%. Or 62.5% is 0.625 as a decimal. So if you get a problem where there's a percentage quoted in a future chapter and you change it to a decimal to work the problem, then you do all your work, and then you're going to change it back to a decimal, back to a percentage at the end. This first problem, all they wanted to do was teach how to change to a decimal first. The other part's coming later. So there's nothing else to that problem. Same thing here, convert to decimal notation. So any fraction, you should change it to a decimal first. 3 divided by 9, whoops. 3 divided by 9, and this is a repeating decimal, 0.33333, repeating forever. Now this calculator displayed about 20 different 3's, and then it ran out of memory space. But the 3's continue forever, it doesn't just stop after a while. The way we write that in math, since us humans, we can't write something that's infinite, it's commonly done this way, 0.3 with a bar over it. That means the 3 repeats forever. So it's not 1 3, it's not 2 3's, it's not 50 3's, it's an infinite number of 3's. So many 3's you could never write them all down. 29 divided by 4. That came out to exactly 7.25. So decimals can stop after a while, or they can continue forever. 7.25. Okay, so now here's where we're converting a percent to a decimal. Change the percent to a decimal because we're going to calculate in decimals. So remember the percentages are bigger, look bigger. 73%. What I do is 73. You can always put a decimal at the back of a number if there isn't one. And you can always add as many zeros to it as you want. So there's where the decimal is located. But if you want a decimal version of the percentage, it's always about moving the decimal twice. To go from percents to decimals, you move 2 to the left because I need this to be a smaller answer. Decimals are small numbers. Percentages are big numbers. So that could be easily forgotten. In the middle of a test, you might go 2 the wrong way. Another way, the reason that's the answer is percent. When you spell that word out, the British actually pronounce that as 2 separate words, or spell it as 2 separate words. They put per space cent. Per means dividing, and cent, like century or cents in a dollar, is 100. So 73% literally means 73 divided by 100. And 73 divided by 100 is 0.73. So if you ever forget, percent is out of 100. And you could either do it in a calculator or you just move the decimal over twice. So you're going to get problems where they'll say 73% of people do this, find the probability of such and such. You never want to work with 73% in a calculation. Always change percents of decimals in calculations. So you would change 73% to 0.73, do your calculation, and then in the end, you might go back to a percentage as an answer. That's very common in other math classes. So here they're just trying to teach you this basic skill that a lot of people have trouble with actually. So find the decimal notation of 42.5%, 2 ways to do it. 42.5%, it already has a decimal in it. If it doesn't have a decimal, put it at the end. When the decimal's already there, to go to a decimal version of this, you go 2 to the left. 0.425 is a decimal version. Or it's literally the number they give you divided by 100. 42.5 divided by 100 is percent. Per means divided by. Just like miles per hours. Miles divided by hours is how you figure out the speed of a car. 0.425, see, same answer. So it's quicker just to move the decimal, but it's safer to do it in a calculator and make sure you get the answer right. It's easy in a test to have a brain cramp and go 2 spaces the wrong way. Okay, now we have the opposite scenario. Now we have the decimal and we want to go back to a percentage. So this is kind of doing this one step at a time in these problems, but it's common in upper level math to have a percentage quoted to you in the problem. You change it to a decimal and do all your calculating, and then you go back to a percent at the end. So this is kind of like the last step of the process normally. But we're doing exactly the opposite of this. So in number 5, we started with 42.5%. We moved the decimal 2 to the left and got 0.425. In number 6, we're starting with 0.22. And we want to make that a percentage. So 2 ways to think about it is you're actually moving the decimal over twice to the right, and that makes it 22.0 or just 22. Or remember that percentages look bigger than decimals do. Decimals are small things. 0.22 is less than 1, but 22 is way bigger than 1. So the percentage should always look bigger. If you thought this was 0022 because you went 2 the wrong way, that can't be right because it's smaller. 0022 is smaller than 0.22. So this is 22%. .11 is what percent? So 2 ways to do it. This is a decimal because they don't have the percent symbol. You could be given 3.11%, but if you are, they have to put that percent symbol. So this is just regular 3.11. This is technically a decimal, even though it's bigger than 1. But no matter what size it looks like, a percentage answer, if they say blank percent, that has to look bigger. This better have an answer bigger than 3. So if you want it to be bigger, you move 2 to the right, and that way it's 311. So this is, size-wise, this is a 3, but this is 311. 311 is clearly bigger. Percents are always bigger. And then the other way to do it is you have to remember somehow to go 2 to the right. When you go from a decimal to a percent, it's 2 to the right. When you go from a percent to a decimal, it's 2 to the left. But again, that could be easily mixed up on a test. So I always remember percents look bigger. If my answer doesn't have the percent bigger, then I did something wrong. Whether they give me the percent or whether they want the percent, just make sure in the end the percent looks bigger. 3 and 311, one of those is bigger than the other. The bigger one should have the percentage symbol attached to it. Okay, find percent notation. Now we're putting it all together in one problem. Every problem up to this point was kind of one step at a time. Now we're going to do multiple steps. First, they give me a fraction 2/5. I've got a fraction. You can't go from fraction to percent instantly, so what we need to do is change fraction to a decimal first. And that can be done with a calculator. 2 divided by 5 is 0.4. Now we want to go from decimal to percent because the question said get a percent at the end. So you got a 50-50 shot. It's either 2 to the right or 2 to the left. You might go the wrong way. So remember, percents always look bigger. If you write them both down, maybe one strategy is write them both down. This would be 0.04 if you went 2 to the left. If you go 2 to the right, you would get 40. This is 0.4. If I put 0.004, that's smaller, but if I put 40, that's bigger. So 0.4 is 40%. And that's another thing too. 40% is really 0.40 because you don't need a 0 at the end of it. You can put a 0, but it's not needed. So 0.4 and 0.40 are the same thing. But 40% is 0.40. Watch out for that versus 4%, which is 0.04. Students get these two mixed up all the time. And it's because they're not taking the time to move 2 to the left. Once a decimal's here, you got to put an extra 0 there. So I did 2 divided by 5 and got 0.4, 0.40. You can always add zeros to the end of decimals. 0.4, 0.40. Then move the decimal over twice and make it look bigger, 40%. If you get 2 out of 5 questions right on a homework or a quiz, you've gotten 40% of the quiz right. Same problem, just a different fraction. So this time they're giving me the fraction 17 divided by 4. This is the fraction, so it's a two-step process. I need to make the fraction turn into a decimal first. That's easy. Then I'll turn it into a percent. In the US, we write percent as one word, but in Britain, they spell it two words. 17 divided by 4 is 4.25. So a decimal can be bigger than 1, but it's still just a decimal. So the percent should look bigger if I'm saying, should I go 2 to the left and get 0.04, or should I go 2 to the right and get 425? Yeah, it should be to the right, because I want it to be bigger than this looks. This looks like a 4. This is 425. Percents always look bigger than decimals do, even if the decimal is bigger than 1. So 4.25 is 425%. Type in integer or decimal, use repeating. Okay, so that didn't apply here because we got exactly this, but that could in theory happen. So there's 100% on homework number 14. Got all 9 out of 9. Save. And oops, both of these are done. All 9 of those are done. Oh, I forgot again about the word of the day. So I already wrote out what my 3 words this week were going to be too, and I forgot to mention it, but let's do this. The first letter is L. Okay, so I've got homework 13 is 100. Homework 14 is 100. This was for Monday, August 1st, these 2 homeworks. Tuesday, August 2nd, we'll work on these 2. 15 has only 7 questions. 16 has 16. So that's a total of 23 questions for tomorrow. 17 has only 7 questions. That's usually a sign that each problem takes a while. And then 18's got 14. So that's 21 questions there. And then there's that 1 question and that weird assignment at the end there, 19. So it's roughly about a little more than 20 questions each of those 2 days. The second letter for today will be O. And I did want to mention one last thing here that this last problem reminded me of. If you divide by certain numbers, sometimes only certain values can come out. So let me show you this on the calculator. If you do 1 divided by 5, dividing by 5 is an interesting one. 1 divided by 5, you get 0.2. 2 divided by 5, you get 0.4. 3, you get 0.6, 4, you get 0.8, and 5, you get an exact 1, but really what that is 1.0. And then it just starts repeating. 6 gives you 1.2, 7's 1.4, 8's 1.6, 9's 1.8, and 10, in essence, is 2.0. So anytime you divide by 5, you always get 0.2, 0.4, 0.6, 0.8, or 0.0 in the final answer. And so when I was teaching at the high school level, I had a statistics class where the students had to take 5 numbers out of a graph. They were supposed to like close their eyes and point at one and do that 5 different times, and then add the 5 up and divide by 5 and tell me what the average of there were different size items, so they had to average the sizes. And then I was making a graph on the board. I was in the front of the room making a graph, and they would just read their answers to me. So I put like 2, 3, 4, 5, 6, 7, 8. And somebody would be like, okay, my average was, I would just point at somebody, what's your average? 4.2, okay. What's yours? 6.6. Oh, I got 6.62, and then 5.0, and 2.8, getting all these answers that are possible. And then I got to this one kid, and he said 3.3. And I had my hand with the marker in my hand about to put the dot on the board, but my hand wouldn't go all the way on the board because I knew 3.3 was impossible. And I just thought, okay, this could happen to anybody. He just must have typed it wrong in his calculator accidentally. And I stopped and I said, you must have made a slight mistake because that's impossible. And then he got all defensive and he like grabbed his paper and held it to his chest. And he's like, you don't know what my numbers are. You can't know that I'm wrong. And I'm like, actually, I can because 3.3 is impossible. He's like, no, you can't know that. And I'm like, okay, give me your 5 numbers and I'll add them up and divide by 5. And then he's like, well, okay. What happened was he didn't do anything. He just was sitting there too lazy to add up 5 numbers and divide by 5. And he heard people saying numbers like 2.8, 6.6. He was hearing numbers like that, and he just made up one that sounded like the rest. He had no idea that I knew that a 0.3 was impossible. And I had to show him, I literally had to show him what I was just showing you guys, that no matter what you have, if you divide by 5, you're never going to get a 0.3. It's completely impossible. Sometimes you can catch people lying or cheating in some ways just because they don't realize what they're doing is impossible. Okay, so the third letter of the day is N. And this video is only 45 minutes, so pretty good for today. So this was Monday, August 1st, homework 13 and 14. And then Tuesday, tomorrow, we'll do 15 and 16. And then Wednesday is 17, 18, and even though there's a third one, 19. That only had one problem, although maybe that one problem will take a little bit of time just because it might have multiple parts to it, but it's something where they want to teach something about a calculator, apparently, because it mentioned calculator in its title. So it's roughly the same number of problems tomorrow and Wednesday, but this one's technically 3 different grades. And then the final letter for today is the letter E. So send that word to me and you'll get credit for Monday, August 1st video. And it was only around 45 minutes, so one of the shorter ones of the semester. See you tomorrow for Tuesday, August 2nd.